So I'm going to start the lesson today by going through that question that I left you with at the end of yesterday's class, which was to balance the following reaction in basic solution. So I want to take you through this bit by bit. As always, the first thing that we want to do is we want to separate the reaction into two half reactions, the oxidation half and the reduction half. So if you haven't done the question, attempted the question at this point, you probably want to do that before viewing this video. I've gone ahead and I've separated them, and I got a bit ahead of myself here, and I took a look at this first half reaction here and noticed that my oxygens were out of balance. I have 4 oxygens on my product side but only 3 on my reactant side. So of course we balance that by adding water to the appropriate side. Now, of course, my hydrogens are out of balance, and so I need to manage that. And the way that I manage this is by adding extra hydrogen ions to the side that needs extra hydrogen ions. And so counting up those hydrogens, 3 hydrogens plus 2 more gives me 5 hydrogens to add to my product side. And so now I'm at the point where I can choose to add my electrons to balance the charge. So when I look at my left-hand side here, I can see that overall there is a 0 net charge. But on my product side, I have 5 positive charges and 1 negative charge. So that gives me an overall 4 positive charge. So I need to bring that back down so that the charges on the left side and the right side are equal. And so by adding 4 electrons in, then I can bring that charge down to 0, and I'm good to go. Now, if I were balancing in an acidic solution, I would be done with this half reaction at this point. But of course I'm not. I'm balancing in basic solution, so I have some extra steps. And the extra step involves adding as many hydroxide ions as there are hydrogen ions to both, not one, but both sides of this reaction. So now that I've done that, I take a look at what results, and what results are some hydrogen and hydroxide ions that would naturally combine in an aqueous situation to form water. And so I'm going to go ahead and I'm going to switch that up to see where I am a little bit more clearly. Just going to clean this up. And so after cleaning this up, I see that what results is that I have 5 water molecules on the product side, but only 1 on the reactant side. So in math, that allows me to do some cancellation, and the same is true in this instance. So by eliminating 1 water on each side, I'm left with 4 waters on my product side and no waters on my reactant side. So cleaning that up a little bit, I can see that I am done at this point with the first half reaction. Now I need to tackle the second half reaction. And so I can see that I have 3 oxygens on my reactant side over here and none on my product side, and so I'm going to add 3 waters to compensate for that. Now I've got a situation where my hydrogen ions are out of balance, and so I'm going to compensate for the added hydrogens that resulted from the addition of water and add those to the reactant side and add exactly 6 of them. So there I go. Now at this point I'm ready to balance my charges. So if I look at the total sum of charges on the reactant side, I can see 6, positive 6 and negative 1 for an overall positive 5 on my reactant side. Looking at my product side, I have an overall negative 1 charge because of course the water molecules are neutral even though there are 3 of them. So that tells me that I need to add in some electrons. And so by adding in 6 electrons to my reactant side, the 6 negative electrons and 6 positive hydrogen ions will effectively cancel each other out, giving me an overall negative 1 charge on my reactant side, and I have that existing negative 1 charge on my product side. But I'm balancing in basic solution, so I'm not quite done. I see that I have 6 hydrogen ions here, and so to balance in basic solution, I'm going to add an equivalent number of hydroxide ions to both sides of my reaction. So again, remember that because I'm deciding on 6 hydroxide ions because I initially added 6 hydrogen ions, and we want to have the amounts of those being equal. But I'm going to also add it on to my product side. So I'm going to do a little bit of cleanup here because of course my hydroxide and hydrogen ions are going to combine to form water. But there is a little bit of additional work that I need to do, because cleanup work that is, because I have 6 waters on my reactant side and 3 on my product side, so that allows me to do some reducing here. So the 3 waters on my product side get removed, and that leaves me with only 3 on my reactant side. So not quite done though yet. Even though I've individually balanced those half reactions, I need to balance them overall. And so that means looking at the charges. So if I have 4 electrons that are being lost and 6 that are being gained, there's an imbalance there. And I need to account for that by multiplying each reaction by some kind of value that will give them the same number of electrons. So the lowest common value here would be 12, and so I could use, of course, 24, but 12 is smaller, so I'm going to work with my smaller numbers. So that means multiplying the first reaction by 3 to give me 3 times 4, 12 electrons that are lost, and then multiplying that second half reaction by 2, 2 times 6 gives me 12, and so 12 electrons gained. So now my charges are balanced. So let me work through that and get the new values. So here are my expanded equations, and so I have no longer any need for these two, the first and the second, or sorry, first and the third equation. I'm just going to get rid of them just to clean up my workspace. And so now I have some canceling that can be done here. I notice 15 hydroxides over here, 12 hydroxides over here. That allows me to get rid of these 12 entirely and change my number of hydroxides to 3. I also notice my waters, so the 6 waters over here can go because I have 12 over here. So taking away 6 from both sides leaves me with 6 up here in this first reaction. Oh, looks like I dealt with my charges first. They can go. There I go. And so I'm left with 3 hydroxides over here, 6 waters over here. I'm ready to combine these reactions to get my final. So here is the final result of this balanced redox reaction, balanced according to it being placed in a basic solution. There will be some homework for you to check out on Google Classroom to help you practice these skills so that you not only become very good at doing this correctly, but also get good at doing it efficiently within a reasonable amount of time. So I'm going to suggest some questions for you to work through for the remainder of the period. And be sure to come and see me if you have any questions or you need some clarification about any point of the balancing.